Myself, Wesley Jacob, Assistant Professor, Rohini College of Engineering and Technology. In this video session, I am going to deal on the subject Engineering Materials and Metallurgy, subject code ME 3392, Unit 5, Mechanical Properties and Deformable Mechanism. In this video session, we are going to discuss on the topic fracture and its types. A fracture is a separation of an object or material into two or more pieces under the action of stress. Types of fractures: brittle fracture, ductile fracture, fatigue fracture, and creep fracture. So first we can see the ductile fracture. In ductile fracture, extensive plastic deformation takes place before fracture. In brittle fracture, no apparent plastic deformation takes place before fracture. The diagram shows the stress and strain involved in the ductile as well as the brittle fracture. The figure shows the brittle fracture in a mild steel and a ductile fracture which appears like a cup and cone fracture in aluminium. So these are the steps while happening the ductile fracture. Next, brittle versus ductile fracture. So there will be a sudden fracture in terms of brittle, and in ductile fracture there will be a neck formation, there will be cracks, voids. After that only the component or the test specimen will fracture. So next we shall see the Griffith theory. Many metals and alloys fracture in a brittle manner. Brittle fracture takes place without appreciable plastic deformation and by rapid crack propagation. The crack propagation proceeds along specific crystallographic planes called cleavage planes. The direction of crack motion is perpendicular to the direction of applied tensile stress. The fracture surface is relatively flat. Most of the brittle fractures are transgranular, that is, the cracks propagate across the grains. The fracture surface appears bright because of the reflection of light from the cleavage planes. Griffith theory: brittle fracture occurs as a result of complete and sudden separation of atoms. The practical fracture strength of engineering materials are 10 to 1000 times lower than theoretical values. He proposed a crack model as shown in figure. The crack is elliptical in shape with a length of 2c. He stated that the maximum stress concentration occurs at the tip of the cracks. This stress concentration reached the critical value, then the brittle fracture initiates. So this is a Griffith fracture equation, which is sigma is equal to root of 2ve by pi c. So this shows the difference between the toughness and brittleness of the text specimen when a hammer is blown.